Okay, so this is an exercise. This is an exercise on just approaching any diagram, ignoring all the words, and just thinking, what can I find? And proving to yourself how many of the formula you actually can find. So think about angles, sides, and areas. Also keep in mind you've got things like arc length and sectors with radians and degrees. So find anything you can. So just take a minute to look at this diagram and try to imagine solving for absolutely anything in it you can. It doesn't matter really where you start, but just pick a place. So I'm going to go through solving for everything I possibly can, but what I'd really encourage you to do is pause this video and really think about what you could do and solve for as many as you can first, and then see what else you can find based on the advice I give. But if you're totally lost, then I guess you gotta listen in. Okay. I'm going to notice that I've got triangles and sectors, and I've got 3 sides here. I know that if I've got 3 sides, I can find an angle. So I might find this angle down here. Call that A, little a, B, and C. So I might just label it as A1. So A1 is going to be equal to the cos rule for sides is cos of A is equal to c squared plus b squared minus a squared divided by 2 times c times b times cos of A. Oops, sorry, too much. 2 times c times b, and don't forget that you need your brackets. So plugging in, cos A is equal to 17 squared plus 28 squared minus 21 squared all over 2 times 17 times 28, and using brackets. And in this problem it doesn't really matter, you could be solving for this angle up here or this one over here. I just picked that one. A little bit of intuition and you'll see why. So go ahead and plug that into your calculator. So you should get cos A is equal to 0.66386. And again, final step, cos inverse of that to give us A, which in this case is going to be 48.40 degrees. Okay, so A1 is equal to 48.40 degrees. Done. Now you could go on and solve for this angle and this angle, and I'll let you carry on to do that. I'm just going to go for some of the less obvious ones to get you started here. Next thing I'll notice is that I do have a sector, and remember that in a sector the radii on it are equal. So those are the 2 radii. So that means this length over here is 28 meters as well. So now I notice that I've got 28 meters in angle and 35 meters. I actually have a sandwich over here. So I can solve for this side down here. And I might call this triangle 1, call that sector 2, and call this triangle 3 just to help simplify things. So A3. So A3 squared is going to be equal to, using my cos rule, because again I notice I have a side angle side sandwich here. So c squared plus b squared minus 2 times b times c cos times c times cos A. So A3 squared is going to be equal to, this is A, I'll call that B, I'll call this C. So 35 squared plus 28 squared minus 2 times 35 times 28 times cos of 29 into the calculator. So this A3 squared, 3 here, sorry, 3 is just meaning from triangle 3, just calling it one thing, A3, is going to be equal to 294.745 meters, well, it's not meters yet, it's still meters squared, and final answer is taking the square root of that, so A3 is equal to the square root, which is 17.17 meters. So now I know this side over here is 17.17, and I've got that angle in there to be 48.40. And what next? So I've got a side, got all three sides, so I could find all three angles inside of that triangle as well. And let's look at the sector. A little bit of information that I could look at here is that I've got the arc length. This is equal to the arc length, and I have the radius. So maybe, if I remember, my arc length formula is r theta, I could actually solve for theta, which is this angle down in here. So the radius is 28, the arc length is 20, and I remember if I do arc length divided by the radius, I can get my angle. So 20 meters divided by 28 for the radius will be equal to theta, and that is going to be 0.71429 radians. Again, theta is going to give us the answer for the size of the angle in radians. Okay. Quickly remembering that we can convert between radians and degrees. So if I want to get from 0.1429 to degrees, I would times by the 180 degrees on top, because that's what I want, and the 2 pi on bottom. Putting that into the calculator, we get 20.46 degrees. So I know that's the size of the angle there. Some of the other bits that we could possibly solve for, as exampled here with the angles. So let's look at some areas. We can also find the area of these bits. So let's go for the area of triangle 1. And remember, you have to use a side angle side sandwich there, so that's 1/2 times 17 times 28 times sin of 48.4 degrees. Plug it in a second. The area of the sector, so area of the sector, is 1/2. Remember, the formula is 1/2 r squared theta, so that's 1/2 times 28 times theta, using the radian one. It's going to give us the area there. And the area of triangle 3 would be 1/2, again using a side angle side sandwich in here, 1/2 times 28 times 35 times sin of 29. So putting those three into the calculator, we would get, for the first one, that's 177.97 meters squared. For the sector, it is sorry, just making sure I had that plugged in right, which I didn't. I forgot the squared. Oops. So taking a look at that again, that's going to be 27.98 meters squared. And for the last one, that is 237.557 meters squared. So if we wanted to do, we could think about doing a total area, adding all those up, and you get your total area. And you could also think about coming back up here and looking for the perimeter. We've got enough information to find the perimeter. You've also got angle side pairs. So just to use the sin rule, maybe we'll go ahead and solve for this one. Let's solve for this angle up here. Call it x. So solving for angle x, using the sin rule, that would be x over, thinking about calling this angle side A, that would be angle A, and then we would have B and B. So sin of A is going, we're trying to find the angle all the way around. Sin A over 35 is equal to sin of 29 over 17.17. And then we want to go sin A is equal to sin 29 times 35 over 17.17. So plugging it into your calculator, we get a size of 0.988. And remember our last step, because this is saying sin A, we have to do sin inverse of 0.988 to get sin A there in that case, and so angle A is 81.209, so x is equal to 81.209 degrees. So there are many more things you can actually solve for here, but here I've done an example of using several different formula. We've used our arc length formula, we've used the cosine formula, we've used it again, we've used the area of the triangle and area of a sector, and we've also used our sin formula, and we've also done radians to degrees. So there we've pretty much demonstrated our knowledge for every single skill. And you can go on to solve for the rest of them, but that's enough to basically cover that in that diagram, if it had a whole bunch of words with it as well, if you can demonstrate what we've just done, you've passed the test. Again, looking for merit and excellence, you'll have to be reading the words and getting on with the actual question.